Input and output. We have talked about programs transforming state. Initial state becomes final state through instructions. But where does the initial state come from and where does the final state go? Today we answer these questions. We explore how programs communicate with the outside world, how they receive data and produce results, input and output. This is how programs connect to everything beyond themselves. A program does not exist alone. It runs on a computer. The computer exists in the world. There are users, other programs, files, networks, sensors, displays. For a program to be useful, it must interact with this world. It must receive information from outside itself. It must send information back out. Without this connection, a program would be useless. It would compute something, but no one would ever know what. The results would exist only inside the program, invisible and inaccessible. Input and output are the bridges between the program and the world. They are how we get data into the program and how we get results out. Input is data that comes from outside the program. Think about all the ways data can enter a program. A user types on a keyboard. A file is read from disk. Data arrives over a network. A sensor measures temperature. A camera captures an image. All of these are input, data that originates outside the program and flows into it. Why does a program need input? Data that originates outside the program and flows into it. Because without input, the program can only work with what it already knows. That is very limiting. With input, a program can respond to the world. It can process whatever data it receives. It can handle situations it was not specifically programmed for, as long as it knows how to handle the type of input. Input makes programs flexible and useful. The same program can process different inputs and produce different results. Remember our model. A program transforms initial state into final state. Where does initial state come from? Often from input. When a program starts, it may receive input. This input becomes part of the initial state. The data that comes from outside becomes data that exists inside the program. For example, imagine a program that calculates the area of a rectangle. The user provides two numbers, width and height. Those numbers are input. They come from outside the program, from the user. Once the program receives them, they become part of the state. The program now has width and height as values it can work with. The program transforms this initial state, width and height, into the final state, the area. Input is the bridge from the outside world into the initial state of the program. Output is data that goes from the program to the outside world. Think about all the ways data can leave a program. Text appears on a screen. A file is written to disk. Data is sent over a network. A speaker produces sound. A motor turns. All of these are output, data that originates inside the program and flows out to the world. Why does a program produce output? Because computation inside the program is only valuable if the results become visible or useful outside the program. If a program computes something but never outputs it, the computation might as well not have happened. No one benefits, nothing changes in the world. Output is how the program's work becomes meaningful. It is how results reach users, systems, and devices that need them. In our model, the program produces a final state, but the final state exists inside the program. Output takes part of that final state and sends it outside. Going back to our rectangle example, the program computes the area. The area is now part of the program state. But knowing the area internally is not useful to the user. The user cannot see the program's internal state. So the program outputs the area. It sends that value to the screen where the user can see it. The output is derived from the final state. It is not all of the final state, usually just the parts that are relevant to the outside world. Output is the bridge from the final state of the program to the outside world. Now we have the complete picture. Data flows in from the outside world. This is input. The input becomes part of the initial state. The program executes. Instructions transform the state. State transitions occur. Eventually, we reach the final state. Data flows out to the outside world. This is output. The outside world. This is output. The output is derived from the final state. Input, initial state, transformation, final state, output. This is the full cycle. The program receives, processes, and produces. It is not a closed system. It is connected to the world through input and output. Input and output take many forms. Keyboard and screen are the most familiar. User types, program displays, but there are many others. Files on disk, data from networks, information from sensors, commands to actuators. The principle is always the same. Data crosses the boundary between the program and the world. Input, data crosses from world to program. Output, data crosses from world to program. The specific mechanism varies. The concept remains constant. When you think about a program, think about its inputs and outputs. What data does it receive? What data does it produce? These questions define the program's relationship to the world. Here is an important insight. Input and output often define what a program is for. A calculator takes numbers and operations as input. It produces results as output. That is what makes it a calculator. A text editor takes keystrokes and commands as input. It produces a saved document as output. That is what makes it a text editor. A weather app takes location and sensor data as input. It produces forecasts and displays as output. That is what makes it a weather app. The internal transformations are important, but from the outside, what matters is what goes in and what comes out. When designing a program, start with input and output. What data will you receive? What data will you produce? The answers shape everything else. Input and output define a boundary around the program. Inside the boundary is the program's internal state and processing. You control this. You understand this. Outside the boundary is the world, users, systems, devices, the environment. You do not fully control this. Data from outside may be unexpected. Input is where outside data crosses into your program. This is where you must be careful. What if the input is invalid? What if it is missing? What if it is malicious? Output is where your results cross into the world. What happens to them is often beyond your control. You can only ensure you produce correct, useful output. Thinking about the boundary helps you design robust programs. Validate input, produce clear output. Know what you control and what you do not. Let us summarize. Programs do not exist in isolation. They connect to the outside world through input and output. Input is data that comes from outside the program. It becomes part of the initial state. Output is data that goes from the program to the outside world. It is derived from the final state. The cycle is input, initial state, transformation, final state, output. Input and output take many forms: keyboard, screen, files, network, sensors, and more. Input and output define the program's purpose. What goes in and what comes out is what the program is for. Input and output define a boundary. Inside is what you control. Outside is the world. Design with this boundary in mind.